We all know that breast cancer is a very bad disease. It kills thousands of women some of our relations that we all know, every single year. And it is by far the most commonly diagnosed cancer among women across the world. Now, breast cancer exists in several different subtypes. And in the lab, I am currently working with ER-positive breast cancer cells. Now, these are just cells that overexpress estrogen receptors. Now, the problem with these cells is that they divide too rapidly, and you end up with the development of a breast cancer tumor, as we see here. Now, drugs have already been developed to beat this kind of cancer, and a very common drug used is tamoxifen therapy. Now, tamoxifen works by blocking those estrogen receptors and slowing down that proliferation rate, or those cellular division rates. And that's exactly what we need. The issue is that approximately 50% of all women who take this drug actually develop a resistance to it. In other words, it doesn't work for them anymore. So now we have a situation where we have a patient who's taking a drug, believing that it is working for them and slowing down their cancer growth. Meanwhile, it's not working, and their cancer is still growing rapidly. Now, in our lab, we are trying to see if there is a way to predict ahead of time whether a patient will show resistance or responsiveness to tamoxifen therapy before the drug is prescribed to them. So we have found that activity in this estrogen receptor pathway actually will control where a protein called N-myristoyl-transferase will locate inside these cells. So we want to try and use NMT as a predictive biomarker. So in the lab, I have taken NMT proteins and I've manipulated them or engineered them so that they will locate in certain places inside these breast cancer cells. And I have tagged them with green fluorescence. And we can see over here on the top, I have cells which are showing me all cytoplasmic NMT. And on the bottom, I have cells which are showing me all nuclear located NMT. Next, I want to take these cells and treat them all with tamoxifen therapy. And I want to see which NMT localization patterns will correlate with tamoxifen resistance and which NMT localization patterns will correlate with tamoxifen responsiveness. We can, if we're able to, when we find solid results, we will see that NMT can actually be used as a predictive biomarker for the development of tamoxifen resistance. In the future, physicians may be able to take a simple test like this, gather the information from it, and appropriately adjust a patient's treatment regime so that they can receive the best therapy and have the best opportunity at survival. Thank you.